Okay, guys, so I think my recording stuff should be working now. Just wait till everyone's ready here. Yep.
When you record, they can hear you and us?
Yep. Well, they probably won't be able to hear you very well. It's taking it from my microphone. So, all right, first question here. Let's do this together. So we are going to do firstly, let's get headphones and cell phones away, please. Thank you. Okay. Okay, so we're going to start with firsts. We're doing root 2 times 5 root 3. That should give us 5 root 6. And then we're going to do outsides, which are these. So I'm doing root 2 times negative root 10. When I do a radical times a regular number, what happens with that? How do we put that together? What happens when I do like 2 times x? What do I do with that? Elise? It becomes 2x. So what happens when I do root 2 times negative 10? Perfect. Negative 10 root 2. Awesome. Andrew, can you grab the back door there for me, please?
Where did you get 5 from?
This. Yeah. This first term. So I did root 2 times 5 root 3. That's 5 root 6. Does that make sense?
Yeah.
Okay. Insides, we're going to do 3 root 3 times 5 root 3. Okay. 15 root 9. And then last, I'm going to do 3 root 3 times negative root 10. That gives me negative 30 root 3. Any questions on that first line there? So far, so good? Okay. Our last thing that we always check when we're doing questions like this is we need to kind of go through and double check and see if there's any common radicals that maybe can be added or subtracted, or if there are any radicals that need to be reduced. So is there anything further that we need to do here? Elise? Great. So 9 is a perfect square itself. So we can actually just square root it and get 3. And then I'm just going to do 15 times 3. That gives me 45. Okay. Is there anything else that needs to be simplified here? No. No? Karen says no. Do you guys agree? No, you don't agree?
No, yes I do.
Yes, you do agree. Okay, perfect. So that is our final. That's good. Okay, any questions from the radicals worksheet? Karen?
When do we get our test quiz back?
You will get it back probably tomorrow. Okay?
I don't want mine back.
No, I'm going to give it back. Okay, questions from the radicals worksheet? Anything? Yeah? Which one? Okay, well, choose a couple. I'm not going to do all of them. Okay, questions? Ones from the back? Anything in particular? Maybe something down toward the bottom here? One? Okay, so 1. Oh.
Oh, are we not going to do number 2?
We're going to, but I'm just going to ask for homework questions before we do that first. Okay, so number 1 on the back, really I'm just keeping that 3 out front and I'm multiplying. I'm just going to wait until everybody's ready here. Owen. Okay, I'm multiplying the roots together. So this is going to be 12 root 72, I think. And then we would be looking for the biggest perfect square inside of 72 so that we can reduce this. So I think 36 times 2 would work for us. And then I can actually just square root that perfect square part. This is on the back of the first page there. Any questions about that one? Yep. Radicals worksheet. Yes, from the last worksheet that we did. Homework. Good, Luca? Okay. Anything else from this worksheet that you guys would like to take up together? Carla.
That one there is also weird, because you can't square root 72.
Okay, hold on one second, sorry. I don't know why we got the idea that it's okay to talk over fellow classmates or myself, but it has been quite bad this week, so you guys need to improve that, okay? Otherwise, I'll just ask you to leave if you can't focus on what's going on, okay? You're here to do what we're doing in class, not speak over people. Sorry, Carlo, go.
So you get 36 and 2?
Yep.
How'd you get the 3 from that? Sorry.
The 3 is already from the original question here,
So you're just
right here.
putting that from the original equation?
Yeah, it's just following down here, and then once I get here, I can just multiply the 3 with the 6, because it's out of the root.
That's just a step you're doing. Okay. I
Yep.
see. All right.
Any other questions from this worksheet? No? Paige.
Can we do number 23?
On the sheet? This one?
Yeah.
Okay. So we're just going to follow along, similar to the question that we just did together in the lesson from today. We're just going to follow along with like first, outside, inside, last. So firsts, I would be doing -2 times 5. That gives me -10. And then I'm going to do outsides. So -2 times -√5. Negative and negative will make a positive. And because one of these is a regular number and I'm multiplying it with a root, those just kind of go together, right? It's like 2√5, just like you do with like 2x. Okay, and then insides, I'm going to do -3√5 times 5, so -15√5. Okay, so 3 times 5, and then the √5 just kind of hangs out on the end there. And then last one, negative times negative makes a positive. And then the 3√5 times √5 gives us 3√25. Okay, so I think we can put these together. If I have 2√5s and I subtract 15√5s, how many √5s do I have?
13.
-13, yep, good. So I have -13√5s. I think we can square root this 25 here to get 5. And then we actually have another constant that can be added with this -10. So I'm just getting 5 from that. Okay, -13√5 plus 5 or 5 minus 13√5. Both of those are acceptable. It's like 1 plus 7 or 7 plus 10. It doesn't really matter the order in which we do that. Any questions for this one? Is that good, Paige? Okay. Great. Good? Anything else? Okay. Let's hop back over to today's lesson then. We'll continue with this. Okay. We're still good. Okay, so this this question right here is a little bit different than some of the radical stuff that we did on Tuesday. If we can do this, we essentially have kind of the concept of what we're doing in today's lesson. So anytime I have an expression with a radical in it, I should be looking at that radical value and seeing if there are any of those perfect squares inside. See if we can reduce it and express it as what we call a mixed radical, right? So we're looking for our perfect squares. I'm just going to jot down. So can someone remind me how we generate a list of perfect squares? If I'm not sure what the perfect squares are, how do I make a list of them? Zion? Or square every number from 1 to 10, yeah. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So I'm just going to make a list maybe up to like 12 squared, and that should probably be high enough. So we've got 25, 36, 49, what's that, 7 squared, 8 squared is 64, 9 squared, 10 squared, 11 squared, and I think that should be enough. 12 squared is 144. Okay, I would suggest that you jot this down anytime you're simplifying radicals. It's good to just like write it on the top of your paper so that you have the list. Okay, so if I want to find the biggest perfect square that is a factor of 80 underneath our square root here, I'm going to start at about the halfway point of 80, which is around 40. So if you want, you can start at like, because 36 is around 40, we can maybe start at 36 and work our way down this list to make sure that we find the biggest perfect square. Okay? So suppose we try 36, we do 80 divided by 36, we get a decimal. Okay, 36 does not go in evenly. Then we try 25, we're going to get a decimal. Okay, 25 does not go into 80 easily. What about 16? 16 works? Okay, so 16 and what? 5, good. So I'm going to split my 80 up into 2 factors. One of them must be a perfect square. How do I know by looking at these 2 factors right here that I found the biggest perfect square? Because we need the biggest one, right, Zion? The second part of that square root, so I did the perfect square first and the factor that makes that equal 80. The second part of that, the 5, should have no more perfect squares as factors inside of it other than 1. We don't really use 1 to simplify. Okay, because obviously 1 goes into everything. We just keep simplifying forever. We don't want to do that. Okay, so we'll split this guy up. So the roots of 2 products are equal to the products of those 2 roots. And then we can just actually square root the perfect square part of this. So we get 2 minus 4 root 5 all over 4. Karen?
I have a question, like, is there a 1 in front of the radical?
Technically, yes. Yeah, there's technically an imaginary 1. We can think about that.
So it'd be like 1 times 4.
Yeah, yeah. We don't really need to put it. We know that like if I just square root that radical part, if I multiply it by 1, it doesn't change, right? So we don't really need to write it, but you can if it makes you feel happy.
I was just wondering.
Question, Maureen? Are you okay? Okay. All right, so at this point, we can actually, oh yeah, Carlos, sorry.
When you're simplifying, you only simplify, like if you have 16 and 5, because you can't simplify 5, you would just simplify the larger ones, so 16 into 4.
So it won't necessarily be larger, but we're actually looking for perfect squares that we can take out of that root.
Okay.
So whenever I split up this is called a radicand underneath the root. Whenever I split that up into 2 factors, I want the first factor that I write to be the biggest perfect square that divides evenly into that number.
So it's just searching.
So it has to be, yeah, it has to be from this list, right?
Yeah.
Okay. Okay, so this is not as far as we can go. We can actually go further with this. But I want to ask you guys a question first. So the foundation of understanding why we're doing what we're doing next, I want to go back to like working with x's. So if I have something like this, okay, let's just focus on that for 1 second. You guys tell me if this is okay or not okay.
No.
Someone says no already, okay.
Yes.
Ooh, So this is equal to 2 minus x? Tony says no.
Why not?
Why not, Tony?
Because he's minus.
Okay. So can you explain a little bit more why we can't cancel from one separate term when those are being minused?
No, it's just not 4x on the bottom.
If it was 4x on the bottom, I still wouldn't be able to cancel those things out.
I don't know.
What's the problem with this, Elise?
I'm not quite sure I know the problem, but
Okay.
you just divide 2 by 4, get that answer, and then divide -4 by 8.
So that's part of why we can't do this, because this is actually equal to 2 over 4 minus 4x over 4, right? It's both of those terms over 4. So what am I doing when I cancel out one of these right here? Well, I haven't canceled it out from this term, and that's a problem. That's why we can't cancel out in those individual terms if I'm adding 2 terms or subtracting 2 terms or even more terms, right? So this is actually equal to a half minus x. Well, when I canceled the one single term over here, I ended up with 2 minus x, okay? And we know that that is not correct. Okay, so this is correct. Canceling out an individual term when you're adding or subtracting, that is a big math crime right there. Okay, so knowing what we know now, we're going to see if we can reduce this. And just as a little note, we usually don't split fractions like that. We usually try to keep them together with a common denominator. So to avoid that, here's what we're going to do. I'm going to focus on the top 2 terms right now. Okay? And the root is underneath a root. So we need to understand if I'm common factoring from a set of 2 terms and there's a root with one of them, I don't take that number out of the root. Okay? Because that number is underneath a square root, and that's a whole other thing. So I want you to think about this as if it was, or as if it were 2 minus 4x. How would I common factor this? Okay, the common factor is 2, and what am I left with? 1 minus 2x, right? So the x stays exactly as it is. Agreed? We're just working with those numerical parts. Okay, we're going to do the same thing with this expression. So we're going to common factor a 2. I open up a set of brackets, just like I did up here. Okay, this is kind of an aside. Now, what is left if I take out a 2 from those top 2 terms there? Elise?
1 minus 2, and then with the
Root 5, yes. So it doesn't affect the root 5 part of that at all. Good? Okay, so I'm just common factoring. Same way that we would if it were 2 minus 4x. And then, now that I have multiplication happening, this is when we get to cancel. Okay, so now that I have multiplication happening here, I've taken the 2 out of both terms. I can actually reduce that with the 4 on the bottom. So I'm actually left with 1 minus 2 root 5 all over 2. Warren?
Can you just run that back?
Which part?
That whole thing.
The last
Like, yeah, when you're canceling it out.
Yeah, so I'm just reducing the 2 and the 4 as if it's a rate. Like, how would you reduce the fraction 2 over 4?
1 over 2.
Right. So that's exactly what I'm doing.
Oh, okay.
Does that make sense? Okay. Yeah, so we're just reducing it as if it's a fraction. Elise? What would I reduce it with? So again, that's the problem with I'm doing it out of one term and not out of both, right? So the reason why we common factor is we see what's common with both of them, and because it's common with both of them, I can actually reduce that with the denominator. But it must be common with both of them, right?
Are we ever going to see questions where it's not common with both of them?
So in that case, you would just be leaving it at this step. Like if you can't common factor anything, then it's done. Yeah. Okay, so this is that expression in simplest form. Okay? Okay, so this is what we're doing today. So if you could do that, we're doing this in the quadratic formula. Did you guys notice that this expression looks kind of like what you have in the quadratic formula when you simplify it? Okay? So here's our goal for today, guys. We are going to, for the first part of this, we are going to express our answers in what we call exact answers. So exact answers, they're in fraction and radical form. The radicals in our answers are simplified, and we use no decimals. Okay? So in this course, we're working toward leaving our answers as exactly as we can. Okay? So let's try it out. So same deal, when I'm doing entering into the quadratic formula, I need something in standard form and set equal to 0. Do I have that right now? Yes, we do. Okay, so let's identify our a, b, and c with their signs and sub them into our quadratic formula. Okay, we're going to simplify. And then when we did this earlier in this unit, we went and we found the decimal values. We're not going to be doing that anymore. We're going to be focusing on just expressing these exactly. So this is the grade 10 portion of this, right? Just getting it simplified. So I have 100 minus 60. So I have 40 underneath here. And then all over 6. Okay? That's grade 10, right? Now the grade 11 part is simplifying this radical and seeing if we can get this into like reduced form, basically. Okay, so 40, biggest perfect square that divides into 40. 16, does 16 go into 40? 10's not a perfect square. 4 and 10. Okay. So 4 is the perfect square part, 10 is the factor that gets multiplied with it to make 40. Okay, I know that 4 is the biggest perfect square because 10 doesn't have any factors inside of it, of course, other than 1 that are perfect squares. So we know that we got it right. Okay, are we okay to just square root that 4 part there? We can just write 2 root 10. We're all good with that? Okay, so we're going to reduce, and then our next step is we want to common factor the numerator. So I'm just focusing on, again, remember the root, after we get it in simplified form, the root stays. Now all I'm doing is focusing on these two numbers right here. So 10 and 2. What's my common factor? 2. Good. So we will remove a 2. We put it out front, open up a set of brackets. And what remains when we take that out of those numbers? Thank you, very good. 5 plus or minus root 10. Lovely. Any questions so far? Paige?
What happened to the 10?
Which 10? This one? We common factored out a 2, right? So when I divide out a 2, I'm left with 5.
So what happened to the 2 beside the 10?
I common factored it out. So imagine I bring this back in now, guys. What are we going to get? We're going to get 10 and 2 root 10. So I'm just taking it out from both of them.
Why didn't you do it to the 6?
We're just common factoring the numerator so that, like, what am I going to common factor from 6? It's just one term itself. In order to common factor, I need at least a couple terms, right?
The other one, we common factored.
No, we only common factored the top.
Didn't we common factor the 4?
So in this one,
Didn't we make it a 1 over?
so we didn't touch the 4 until we reduced. So now we're going to reduce. Okay? So I think you're getting ahead of me. Okay, so what can I reduce 2 and 6 by then, Elise? Yeah, so it'll be like 1 over 3. And so I now have 5 root 10 over 3. So the 2 and the 6 get reduced by 2. Okay, so my two options here, my x1 is the plus option, 5 plus root 10 over 3. And my x2 is the minus option. Okay, these are the exact coordinates of my x-intercepts. Okay, so we're still finding x-intercepts with this quadratic formula, we're just expressing them as exact values. Okay, questions on this before we try another one? Okay. Is everyone good if I scroll?
We leave it there once we're done with it, right? We don't have to simplify or
Yep, that's
solve
it.
Okay.
Yep, you're done.
All right.
Okay. Guys, I also want you to keep in mind that not every root that you get here is able to be simplified, right? If I have the square root of 51, there are no perfect squares that divide into 51. So actually, with this method, if there's nothing that I can reduce this root into, like if I can't simplify it at all, I'm actually done right at this step, and I just split it and I'm done. Okay? So that's the cool part about this, is like, if I can't go any further, then I'm literally done at this second step right here, and then I split and I'm good.
That'd be a great example.
I know. Just a whole test of that, right? Okay, let's try another one. We're going to sub into quadratic formula. Okay, my hope is that we can be pretty quick at this point, because just the first simplifying part, because this is from grade 10, right? It's just plugging in and calculating. You should be really fast at what we just learned already. Okay, so we have what, 64 minus 40? So 24? You don't? Well, believe it. I did it. Okay, so far so good? Okay, now we're going to reduce this 24. So we need to know, what is the biggest perfect square that divides into 24? It 9? Okay, 4. 4 and 6. Yeah, 4 times 6 is 24. Yep. You're testing me, right? Okay, and then we'll square root the perfect square part of that, which will give us 2 root 6. Any questions so far on those first couple steps? No? Okay. Little tip for you guys. You'll notice that we have a negative in the bottom here. It might be helpful for us, especially because this first term right here is also negative. It might be helpful for us to common factor out a negative, because I can kind of foresee that if I common factor out a negative, I'll be able to cancel the negatives, the negative on top with the negative on bottom. Okay? So when I common factor here between the negative 8 and the 2 here, what would I be taking out? A negative 2, yeah. Okay, and I usually only do that when my bottom is also negative, so that I can cancel the negatives. Okay, so the question is, what is left? Okay, so see how we have a plus minus here? If I take out a negative from both of those, I just get a minus and a plus, so it doesn't actually change, right? Because both of the signs are there. So if I switch both of those signs, I just end up back with a plus and a minus there. Does that make sense? Okay, but my first term is now positive, right? I have a positive 4. And I still have I have a minus plus, but it doesn't really matter the order in which we put that. And I've got that root 6 there.
Why is your first one 4?
Because I took out a negative 2 from negative 8. So then I'm left with 4. Right? When I common factor, I'm dividing out the negative 2. So negative 8 divided by negative 2, left with 4. Okay, now I should be able to cancel. So the negative and negative will cancel. Negative and negative make positive. And 2 and 4, that reduces to just a half. Oh, no, never mind. Sorry, I thought I did something wrong, but I'm good. Any questions so far? Okay, split into your 2 options. Plus and minus. And those are our answers. Yep. Where did the 4, this one?
Took out 2 from negative 8, negative 2 from negative 8.
That's what I asked.
Does that answer your question?
No,
No?
no. Wait, what 8? Oh, that one.
So I had negative 8, I common factored a negative 2. So when I divide negative 8 by negative 2, what's left? 4. You got it. Owen? No, we don't do that. It's like writing 1x, Owen. We don't really do that, right? It's understood that 1 is, yeah, I would probably take off 0.5.
Really? You put a 1?
Yeah,
What?
I think you guys should, well, if I have 1 times a bracket, it's just equal to that bracket, right? So if you put the 1, I expect in the next step that that 1 is gone, right? When you, but if it makes you feel happy to rate the 1, you can write it. But then in your final answer, I don't want to see that 1,
Okay, so
right?
like while we're doing our work, if I want to put a 1 in front of 6.
In front of this?
It's freezing. No, never mind.
Okay.
I got it.
Chris? Yep. Okay, why don't you guys try the last one? See what you can do with it. See if you can get it fully simplified. I'll put up my answer in a second. Pause this. Okay, check your work as you go with mine. Do you say that's not fair she doesn't use a calculator? So shouldn't you have an advantage over me?
That's what makes it not fair.
You don't have to plug it in. You just know it.
Exactly. We don't.
Well, you guys got to practice then, I guess. Oh, oops.
Did I do it? I did it.
You did it? Wow. Okay. All right, let's bring it back in here. Just wait till everyone's ready here. Okay. Check your stuff over. Are there any questions on how I got any of these things?
What's the point of doing this?
So our whole idea is we want to find the x-intercepts exactly.
No, but like in life.
I will just answer your question in general. I think that, sure, you might never use the quadratic formula to find x-intercepts in your daily life. Agreed. Some of you may use some of the math that you learn eventually if you decide to go into something that has to do with math. You may not. But I do think that the problem-solving skills and the numeracy skills, critical thinking skills that you get from doing math like this are very helpful skills that you do need in your everyday life.
Okay.
So that's my answer. Hopefully that's good. Thank you. Thank you. Thank you.
I was just like, I don't understand why it's good for you.
Yeah. No, I just think that the skills that we get for that are good skills to have, right? Okay, Owen, question. All right, shh. I can't hear Owen at all. Silence. Okay, go, Owen. Oh, you got it? Okay. Any other questions?
Can you go over the from the 4 plus or minus 2 10 squared
Here to here?
to there?
Okay, so I'm just common factoring. So what I would like to, gentlemen, Owen. Shh. Okay, so what I would like to focus on at this step right here is the 4 and the 2. What's common between 4 and 2? What can we take out of both? 2. So that's where I get this 2 from. And then I divide both of those numbers by 2. So 4 divided by 2, what do you get? 2. And then when I do 2 root 10 divided by 2, the 2's are gone. So the root 10 is just what remains. Right? Does that make sense?
Yeah.
Okay. Awesome. Okay, we're going to take a quick break, and then we're going to talk about a new kind of notation, okay? So take 2 minutes.